I need to prove triangles are congruent. Now, there's a huge hint given, as there quite often is, in the name of the learning target. Prove triangles are congruent using side, 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 angle, or angle, angle, side conjectures. Those are the only conjectures I have to prove triangles are congruent. So if I get that side, side, angle conjecture, I'm going to know that it's the one that doesn't work because it's not one of the ones that's given to me as a huge hint in the names of these learning targets. So I look at this triangle and I start to think of what I know based on what's given to me. Well, I know that these two sides are congruent because it showed me that. I know that these two sides are congruent. I know that this is congruent to itself. So probably the fastest way to prove these triangles are congruent is to use the side, side, side congruence. Now notice I put 3 marks on this one because there was already the 1 marks was used and the 2 marks was used. So RAB, E would correspond with R, so it needs to go first. And then going along the side with 1 mark to A, from E going along the side with 1 mark to B, and then along the longer one to A. That's not the only way that you could have done this. You also could have taken the fact that they showed you that these pairs of parallel lines were congruent, or sorry, that these lines were parallel, to say, well, if these two lines are parallel and this is my transversal, these alternate interior angles here are congruent. And then using the other set of parallel lines, if these two lines are congruent, or sorry, parallel, and this is my transversal, then these, notice again the different notation here, these angles are congruent. So I also had the option of using angle, side, angle, or angle, angle, side, depending on which. I had a whole bunch of choices on this one. I just thought the fastest one was side, side, side. So it shows me that segment AC is congruent to segment BC. Now I can't just put 1 mark on one side here because then I wouldn't know what it's talking about. So when there are a couple of different things it could be, I put this out to the side. From A to C is congruent to the side BC. Maybe I'll even put 2 marks on there. Because if I just put a mark here, is that talking about the distance from A to D or A to C? It's really, if I put it there, it really means from A to D. So I don't want to do that. And segment BD and segment AE are medians. Well, if segment BD and segment AE are medians, it means that they bisect the opposite side. So I know that this is congruent to this, and this is congruent to this. Now, I would put these 3 marks here like this normally, but I also know that if these two longer sides are congruent, and I just bisected each one, then really what it means, I don't have to put those 3 marks. I know that all 4 of these segments are congruent to each other. Now, it looks really confusing, but I can go back and I can say, well, one thing I know immediately, and I usually mark this down right away, is that this side is congruent to itself, and see if that helps me at all. Now here's where it can get to be a little bit challenging. It's hard to know sometimes with these more complex figures what things I want to show are congruent. I obviously have vertical pairs of angles here that are congruent, but if I pay attention to what they're asking me about, they're saying triangle ABD. So I'm just going to do an outline line on triangle ABD. And what I know already is that I've got this side congruent to a side from another triangle, and this side congruent to a triangle. So I've got to be dealing with these 2 triangles down here, which means these pairs of vertical angles being congruent, they aren't going to help me at all. What I need to find is in this larger triangle that I just outlined, a pair of an angle that's congruent to another angle, so like angle D congruent to angle E. First of all, I can't show that. Secondly, it wouldn't help me because that would be a side-side angle congruence. Maybe the third side, but there's nothing that tells me that side DB would be congruent to side EA. There's nothing in the notation, nothing that I'm given that would help me with that. What I am given, and this seemed almost like a throwaway to begin with, is that this side of this larger triangle is congruent to this other side of this larger triangle. So this large triangle is isosceles. And if the large triangle is isosceles, it means that this angle, oops, let me change that to here. This angle is congruent to this angle over here. Now, if I look at what's happening with ABD, I have this side congruent to a side from the other triangle, this side congruent, and this angle. So I have a side-angle-side congruence going on over here. And if I'm talking about ABD, then the other triangle must be BAE. Again, in these more complex figures, it can be really difficult to figure out what congruencies are going to help you and how to do those. Sometimes using a highlighter or something just to outline one of the triangles you know you're working with helps you to focus on which angles or which sides might be helpful to me. Now, problem 7. Triangle SAG is congruent to triangle something. So they've given me these two angles are congruent, and, well, I know that this is a 72-degree angle, so this angle is congruent to this angle. Now, they give me 62 degrees and 46 degrees. I need to probably do a little bit of work to show if this is a 46-degree angle or not, just to make sure. So I'm going to use my triangle sum inequality and say 180 minus 62 minus 72. So that's 180 minus 134, which is 46 degrees. So I know this angle down here is congruent to this angle down here. And again, up here, this angle would have to be congruent to this angle. So I actually do have congruent triangles here. If I'm looking at triangle S, which is the 62-degree angle A to the 46 to G, then it would have to be LOI. Now here's where I have a couple of options. Because I know all three angle pairs are congruent here, and I know a side pair, I could do angle, side, angle, or I could do angle, angle, side. Either one of those with my markings would be perfectly acceptable. I'm just going to put angle, side, angle. Here's another one of those complex ones. So before I even start marking anything, I'm going to outline one of the triangles that I know we're dealing with. It says ADB. So this is this triangle here. The focus is, again, what triangles I'm looking at. It means I'm not looking at these two smaller ones on the side. Now what I know is that segment AC is congruent to segment BD. Here's where this also gets to be a little bit challenging. I can't just put a mark here, because a mark there really looks like segment AE being congruent to something. So the notation is a little weird, and sometimes it makes your problem even a little more complicated, but for now we're going to mark it on there. All the way from A to C is congruent to all the way from B to D. Again, we're going to probably break this apart in a little bit to make it a little bit less complex. And side AD, oops, I'm going to do 1 there, is congruent to side BC. Now I'm going to pull that triangle out that I just marked on. What I know is this side is congruent to the side from the other triangle. This side is congruent to the side from the other triangle. What I don't yet have is another congruence that's going to help me, but if I pay attention, this bottom side is shared by both of these triangles. So I actually do have a third congruence, and this ends up being a side-side-side congruence. And if I'm doing ADB, then over here I should be doing BCA. And last but not least, when I look at this, the first thing I notice is I have vertical angles here, and they're talking about ABC, so this triangle. When I do this, there's already a 1 mark on this one, so this one needs to be 2 or 3 or something other than 1. So these two are congruent to each other. These other two on the outside are congruent to each other. Now, I do have 2 congruent triangles because I have an angle, side, angle congruence. And if I'm starting at A, then to B, then to C, I have to go from E to D to C on the other one.